Hello everyone, this video is going to be a short introduction to installing and running the sample files for the Consolidated Fire and Smoke Transport, or CFAST model. So when you go, you can download the software for free off the NIST website. So if you use your favorite search engine, just search NIST CFAST and it'll take you to their download page. So I'm going to show you CFAST version 7.2.4, and it installs like any other program. And when it installs, it's going to create basically, at least on this computer when it did it, it created a file under the C drive, program files, fire models, and you got two folders, CFAST 7 and SmokeView version 6. So CFAST is obviously the model and SmokeView is the program that's going to do the visualization. Now I wanted to show you where these files are located because there's a couple of things in here that we want to be able to use. First off, there is a thermal file, and so this contains thermal properties for materials. I'm going to show you where and how to add these into your CFAST model. Also, you have an allfires.in file, and that's going to contain a variety of sample input files. So the first thing I recommend people do is try to run an example file. And so along with the documentation, the user's guide, technical reference guide, etc., there is an example that comes with this. It's called user's guide _example. Now the old versions of CFAST, the example file was called standard. It was just called standard.in. So if you're used to seeing that as your example, they've changed the name. And it's a better example. There's a lot more stuff included in this new example compared to the old one. So to run CFAST, we can either open it we can search for the program on the computer, or we can double click on the C-Edit application. And when it opens, you might notice it looks like the screen is cut off, and it is. So a couple of things you might have to do is you might have to change your screen resolution. I've had several students say that helps, that fixed the problem. When I maximize the window, now I see these 5 buttons on the bottom, and I can see this no error message. And so I'll show you as we go through, if your input file has any errors, they're going to show up here. It's not a foolproof way to know that your model is good, but the obvious errors will show up, which is handy. So the first thing we want to do is try and run our input, or our example that comes with it. So when we click File, Open, it takes us to the working directory, and so we click on our examples, and we'll just click on our user's guide _example, and you'll notice they use underscores rather than spaces. So the last time I was aware that the program did not like spaces in input file names. So I always recommend people use underscores rather than spaces for CFAST. So we open this, we can see some things changed on this first page, the simulation tab. And so the model, you have a variety of tabs. The first one, simulation thermal properties, we'll go through them. This first one covers simulation time, how often output is going to be generated, the initial simulation conditions, both inside and outside. We have a thermal properties tab. It's going to talk about if you don't assign thermal properties, you can have the model just treat the walls as inert. Now, if we wanted something other than concrete, we could choose, and we wanted to use one of the input parameters. And now that I've gotten to this point, I remembered I was supposed to do a disclaimer. And so I wanted to say a short disclaimer. I'll have the full thing in the description, but this information is presented for educational purposes only. It is believed to be accurate and reliable, but no warranty is expressed or implied as to the accuracy of this information. Neither the author nor the publishers assume any responsibility for this information contained herein. This information must not be directly used for life or property safety purposes. Solely used. The user is obliged to obtain professional guidance for any decisions affecting safety of people or property. And on that note, these provided input parameters, as far as I know, they are not verified input parameters. So I would not want to go to court and have somebody check my model and say, where did you get the conductivity for concrete, and say it came with the model. I just used the default parameters. That's not a good response. But as sample input parameters, they're fine. For learning the program, they're fine. And then when you do use this for real, you just want to make sure you double check and the thermal properties you use come from a reliable source. So to get other parameters that come with the file, we're going to click From File. We're going to go back to our CFAST folder. We're going to select all files from this pull-down menu, scroll down, click Thermal, click Open, and then we have a selection, a pretty good selection of different materials, and we can select one and use that one, or we can select all. You can select one or several. You can select all and click OK, and then they all come into your model list, and you can select which one you would like to use for your model. Now, the next tab is compartments. So this is going to define our compartments in the model. And we have 3 for this case, and the major ones to look at are the width, depth, and height, and then the position. And there are flow characteristics, so you can do normal 2-zone model, a single zone model, or a corridor, which has a revised ceiling jet as identified here. Now you notice the position Cartesian coordinates are 0, 0, 0 for the first model. They're 5, 0, 0 for the second compartment, and they are 5, 0, 3 for the third. And what this means is that our first compartment is sitting sort of in the corner at 0, 0, 0. Our next compartment is sitting next to that, 5 meters over on the x-axis. And then our third compartment is sitting on top of the second compartment, 5 meters over on the x-axis and 3 meters up is its bottom corner. So you identify the materials for the ceiling, walls, and floor here. You can turn it off if you would like to not deal with that. You identify vents. So if we select we have 3 vents here, you're going to select the first compartment and where it's going to go to. You're going to set the sill soffit width, the offset from the side, and the face that it's going to sit on. So you can pick front, right, rear, or left. You can also have you can change the condition, right? So if it's initially open, you can have it, or if it's initially closed, you can have it open at a specific time or a specific temperature or heat flux. So that gives you a lot more options if you're trying to model a scenario where maybe a door was opened at a certain time, or a window broke, or a wall burned through. Similar situations for the 2 other vents, except now instead of going from compartment 1 to the outside, now we're going from compartment 1 to compartment 2. We have ceiling and floor vents. Now I haven't used ceiling and floor vents much myself, so this is an interesting, you can have a round vent. It's the only situation in CFAST that I know of where you can have a round bit of geometry, so that's quite interesting. I don't know a lot about it. Mechanical ventilation is what it sounds like. You specify a flow rate. Similar to the others, you're gonna specify one compartment to the next. Areas, center height, etc. I haven't used a lot of mechanical vents. Fires, these get interesting. So I want to mention there are a lot of default fires you can choose from. So if, let's say, we wanted something besides the cushion and the wood wall that are identified here, we could, if we wanted to use a default one, we could go from fire. We could select all fires, click open, and then we have a variety of tests that were done at NIST. 3-panel workstation, bunk bed, kiosk, mattress, box spring, etc. Now we want to be careful when we use the default heat release rate curves. So these curves were done under a fume hood. They took the material. You can go to the NIST Fire on the Web website. The name may have changed, but as far as I know, the videos are still there. And you can watch videos of these different tests. And what they did was they burned them in the open under a hood. Now the heat release rate curve that's generated from that isn't necessarily physically possible inside of a compartment with a limited ventilation condition, where maybe you have a window open, maybe you have a door open. There may not be enough air being entrained into that room from buoyancy driven flow to fuel the fire that you're trying to fuel the heat release rate that you're putting in the model. So the model won't figure that out for you. So that's where you as a user need to be very careful and deliberate about what heat release rate curves you put into the model. Besides picking from the default, I like to use t-squared growth rate curves, especially for demonstration purposes, because we talk about t-squared growth rate curves in class. So you can select t-squared growth rate. You can select from slow, medium, fast, or ultra fast. You can change the peak. Now I like to leave the peak at a megawatt because we talk about how in the several pieces of literature that says the t-squared growth rate curve is accurate up to about a megawatt, and then it's not necessarily an accurate prediction of the growth rate after that. Not guaranteed to be wrong, but it's also not as accurate. So check your literature for how you want to describe your heat release rate curves. We can change how long the steady state period is going to last. We can change how long maybe the decay period is going to last. So when we add, let's say we added a new one. This is where now we see an error message. I like to point out we see an error message. We see fatal, it's a fatal error, so the program won't run. We see fire 3 is not a sign of existing compartment. So even though it says, if we click on fire 3, it says compartment 1 here. I don't know why. It's sort of just the default. So if we physically click on compartment 1, that error goes away. So for whatever reason, that error or that default is a thing. Also, if we were to add a new fire, you'll notice the default location is -1, -1, -1. So we want to be careful that we don't leave our fires at that location. Okay, let me delete these, because if I have errors, whoops, I did not want to duplicate that. I wanted to delete that. Remove. I meant to hit remove, not duplicate. So we had 2 fire to start with. I'm gonna get back to our 2 fire situation. No errors. So that's good. We can put in targets. We can put in a variety of targets that might measure things such as heat flux. We might put in different types of detectors and suppression. So sprinkler, smoke detector, heat detector. We might identify service connections, specify some things there. I haven't done a lot with this tab. And we might mess with the output. I also haven't done a lot with this tab, so I'm not exactly sure what all these parameters do. Now that we've sort of gone over the different tabs, we want to try and run our example. So remember, when we clicked open, we went to our basic user's guide in case I made any changes and didn't delete them. I'm going to open it again. I didn't click save, so nothing should happen. So I come down here. Typically I want to save my work before. You have to save it. If you made any changes, you have to save the file before you run it if you want those changes to be taken into effect. If you want to check your geometry without running the whole model, you can click this geometry button. We can click run, and what we should see is a progress bar propagate across, and then compartment temperatures and other conditions listed here in this table as a function of time. And we're not seeing that, so that's not good. And what we might notice is that these files are located in the program files folder, and so I'm not sure what the permissions issue is, but on this computer I can't run the model as it is generated in the programs file folder. But if I make a folder on my desktop, I can copy this model there, and if I go back to my program and I go file open, I'm going to go to my desktop, open this version of it, and click run. Now we see the progress bar going across, and we have conditions in the different compartments being listed. So what we want to see is this finishing. We'll hit close, and then we can click view, and here is our smoke view representation of the model. And if we right click on this, we can go to load. We have a variety of different things, but what a lot of people look at is your zone file output. And so we can see our upper layer temperature and height represented sort of in physical form by these colored rectangles. We can see our fires are represented by these orange cones. And the color of the upper layer is representative of the temperature using the spectrum on the right. And then our flow rate through the vents is indicated by the size of the shape coming out and the color of the shape. And while this is a useful pictorial representation, it's hard to get hard data from this. So let's say we're doing an A set versus R set analysis, and we have some criteria that says, okay, we need everybody out of the building before the upper layer height reaches 6 feet above the floor. And so it's hard to say, okay, when does the layer height meet 6 feet above the floor? And so to get that information, rather than looking here, we can look at our folder. Now if you look at the folder, this is the folder on the desktop where we copied our .in file into to be run. We have a whole bunch of new files that were generated by the program. This is the SMV file. That's your smoke view file. So if you double click on that, it will open smoke view, assuming smoke view is installed on the computer. Now, I believe I mentioned earlier that if you don't have administrative rights to your computer and you need to run smoke view, or you need to run CFAST, so I've had several students who don't have administrative rights, or they own a Mac, and so they want to run the program in a computer lab or a library. If you copy the files from CFAST from the fire models folder, CFAST7 folder and the SMV6 folder, put it on a flash drive, you can run these programs directly from the flash drive. A lot of times I'll copy them directly to the desktop so you don't have any lag from sort of the file transfer speed of the USB, though modern USBs are pretty fast. But you would just double click on the cedit application and it seems to run fine. Currently, CFAST is only compiled for PCs through NIST as far as I'm aware. But if you Google CFAST for Mac, you will find a website created by Dr. Overholt with directions for recompiling the program for Mac. Now, those directions were made in 2011, at least currently, the ones currently on the website. So I'm not sure if they work for the latest version of CFAST, but if you are a Mac person, there are some options available. Okay, so I wanted to talk about the user's guide, not the user's guide, the output files. So we have a variety of Excel spreadsheets. Well, they're spreadsheets. They can be opened by any spreadsheet folder, not just Excel. So I'm going to go from the bottom to the top. So if we look at the underscore zone, I forget what these parameters are, to tell you the truth. So check your user's manual. Clearly I haven't used these parameters too much in my use of the program. So we'll go on to the W, underscore W. This is where we get our temperatures in for the sort of the walls, the ceiling, and the floor for our compartments. So units of Celsius, ceiling temperature, upper wall temperature, lower wall temperature, floor, and then it's going to go from compartment 1 to compartment 2 and propagate along through however many compartments you have. I have forgotten what the maximum number of compartments CFAST will allow you to use. It's a fairly large number, but it is in the user's manual. So underscore the underscore S Excel file and the underscore M Excel file seem to have similar information. Now, I don't use this a lot because I don't specify yields in the models, but you can if you want to. So you want to be careful when you use, if you're going to use these output parameters, CO2, CO, HCN, HCl, unburned hydrocarbons, you need to specify these inputs in the model. So if you just leave it as the default, the numbers you get aren't necessarily representative of the fires that you're trying to model. Basic fire modeling sort of mantra is bad information in is bad information out. So using the default is probably going to be bad information in. So be aware if you want to look at gas yields, gas concentrations, species concentrations, look in the user's guide, make sure you do your inputs correctly for that. If we look at underscore S. We haven't looked at that one. Oh, we did. S and M were the same, the ones that had similar output. If we look at N, this is the one I look at the most. So this is upper layer temperature, layer height in the different compartments, lower layer temperature, etc. Now, these numbers are in scientific notation. If you don't like scientific notation, I've had some students who aren't comfortable with that. So if you sort of hit this upper corner triangle and you go to home, you can set them as either a general or a number, and then they'll go to be displayed as a normal number. If we go to underscore F, we get vent flow rate information, units of kilograms per second, etc. There should be one of these Excel spreadsheets has the information from the targets. So if you have, and your sensors, so your sprinkler, your smoke detector, and the heat detector, that information for those will be in one of the spreadsheets. Alright, so I ran the example, I showed smoke view, talked about thermal properties, talked about the example folder and need to move that potentially, talked about being able to run the files from a flash drive, which comes in handy fairly often. And I think that's everything I wanted to cover. So I hope you found this useful and have a good day.